There is a lot of power within a single ignition server, but in some cases, you're going to need more than one ignition server to get the best performance. Our scale-out architectures offer a lot of power and a lot of options that you should consider. To help you with that, let's just take a look now at some ways that Ignition helps you scale out your system.
So in larger systems, it's often easier to have multiple Ignition installations. This is perfect for large systems that aren't split up to different sites. So this would be on-site, more or less taking a single Ignition gateway and splitting it into multiple gateways. Hub and spoke is normally better fit for systems that are split into different sites, but for a single site, this scale-out architecture is great. Just for reference, this is the architecture that we're talking about with IO and front end split out there, or multiple IOs, or multiple IOs with OPCUA or MQTT connected there. The scale-out architecture has at least one Ignition gateway that handles backend communications. The backend talks to PLCs, does device communication, does MQTT communication. It also does history, and it does alarming. Front-end gateway handles the clients, so it serves up the data that is pulled from that back-end gateway, and is possible through the gateway network. That interconnection there is a protocol that we call the gateway network protocol. That is a specific protocol that was created by our developers. So that gateway network communication there is what allows for the tag sharing, remote tag provider sharing, history sharing, and other communications. One of the nice things about the gateway network is that it is a dedicated HTTP channel. So it sets up as a node, or it can actually proxy to other Ignition gateways as well. In the cloud architecture that I showed earlier, you had multiple Ignition gateways that were talking to each other, and they can proxy to each other through the gateway network communication. There are security settings, and so you can restrict connections, you can whitelist connections, you can set security on individual services, so you can set it up so that there's read-only access from the outside, or read-only from certain zones, or disabling access entirely, or read-write from certain zones. So the front end, you'll want to have read-write. From the cloud, you might just want that to be a read-only connection and have zero chance or possibility or zero permissions for anyone to change anything if they're coming from the cloud. That's easy to set up. And SSL is available, so you can have full encryption, and in fact, that's turned on by default. More gateway network features here. The enterprise administration module uses the gateway network, and so it's used for monitoring things, centralized backups, license management, and resource distribution, any changes that you might want to make remotely. And then there's also remote real-time providers, historical providers, alarming, alarm journal, audit logs, and all of those are remote services that allow one gateway to access information on another gateway. So you can have a central designer pulled up, for example, where you can browse all the tags and all the rest of the gateways. And in fact, you can configure additional tags on other gateways over that gateway network connection, as if you were on that remote system. So you can browse its devices, you can browse its OPC side, and you can pull in new tags like that. We already mentioned security zones and service security there. So this is a quick example of that scale-out architecture. You might start from a single Ignition gateway or the standard architecture we talked about earlier, and then split it up into a scale-out architecture like this, where you have a front-end gateway and an IO gateway that are basically handling the load for those different pieces. So IO is talking to devices, or talking over MQTT, or talking over OPCUA, and then the front end is talking to the back end, or that IO gateway, and it's also talking to the SQL database there. And clients can be anywhere. Often in this case, with the scale-out architecture, these would be on-site, but they could be connected from remote over a VPN, or really anywhere that has IP-based access to that front-end gateway.
Quick question.
Yeah, go ahead, please.
In the back end, front end gateways architecture, which one would handle database connection for history insertion?
Great question. So the IO gateway does that. The IO gateway is going to be putting that data, the history insertion, into the SQL database. Basically, the tag historian module runs there, and the SQL bridge module. Since it's the one that is seeing those tag changes live, it's the one that is most appropriate to be doing that data insert into the SQL database. If you have 15 IO gateways, and there's certainly folks who have really large scale-out architectures, you can pair it up with one additional Ignition gateway that's just dedicated to the historian. And I have seen some folks do that. But in general, that IO gateway is going to be doing that job. It's going to be putting that data into the SQL database, both for tag history and for any transaction groups, any event-based history that might be going in there. And then the front-end gateway can be set up so it is pulling data either through the IO gateway, or it can pull it directly from that SQL database in a way that's transparent overall. It's a really nice setting inside that gateway network, the remote history provider that might be set up there, or the remote tag provider. You can say, I want to pull history directly from this database, and that front end will issue queries directly against the SQL database instead of making an additional hop through the IO gateway. But you can set it up in either way.
Kevin, one last thing. Since we're talking architectures today, I think I should interject this question right on topic now. And it says, when using a scale-out architecture with a third-party OPCUA server handling device communications, is it still recommended to have a separate gateway purely for handling front-end clients?
It depends on your load. So in some cases, this can make sense. In other cases, you might be able to do a single server architecture. So most folks actually will take a look at what they think that the overall sizing might be, how much history they're going to be storing to the database, and how many front-end clients that they're going to be looking at, and then decide based on that. The IO gateway, that one is going to be largely responsible for history insertion. And if you have a really large amount of history, that load is going to be heavier than any sort of native device communication load on that server. And so it can make sense to have it split out. If you have 100 tag changes per second that are coming through, or 500 tag changes per second coming through, so some number that's not too large, it's probably fine, and you've got 50,000 tags, it's probably fine to have all of that in a single Ignition gateway here. But if you're looking at really large numbers, it might make sense to split it out. All right, and so one other architecture here, and this is actually exactly what was just asked, that OPCUA server there, whether that's Kepler or whether that's Ignition or whether that's Autosol or whether that's a third party's OPC server like BNR has their own, regardless of where it's coming from, this architecture can make sense. And so yeah, this was the question that was just asked. Does it make sense to have an IO gateway if you have an OPCUA gateway? And the answer is yeah, it certainly can if you have large enough numbers of clients and you have a large enough number of tags that have tag history that are associated with them, or large number of transaction groups. In this case, this is showing if you're using Ignition's OPCUA server, this diagram is showing that it can make sense to have that split off as well, because that device communication, the driver communication, if you have a few hundred devices, can be one of the heavier pieces overall in terms of the amount of CPU that's needed for that utilization, and having that inside its own server right alongside the IO server can be a nice way to have that isolated and have that dedicated to PLC communication, whereas the IO server is dedicated to processing those tags and the history and alarming and possibly reporting. Sometimes that's done there as well, and then sending any value changes to the front end for the clients. One other architecture for scale out is this architecture where you have two different IO gateways, or 3 or 4 or 5, and you have a front end gateway that's separated out from that. This is also useful if you have really large numbers of PLCs that you want to be coming through. They might even have geographic separation, or they might not. They might be on different networks. And so folks often use this architecture overall. This is one of the more common scale out architectures. A couple of best practices around this. For the tag providers that you have inside these scale out architectures, you want to make sure that you provide proper names to those tag providers. You don't just want to call them default. That's where they start out, but when you set up those IO servers, make sure that you name them something that makes sense. And you can have multiple tag providers per IO gateway, or you can have a single one. The important thing is that the front-end gateway is going to see those tag provider names, and having those consistent is going to help a lot in terms of the way that clients are designed. And if you did need to move some devices around, or you needed to move an area to a new IO server, if you have good names for those tag providers, you can move an entire tag provider to another IO server and have zero work that you need to do on the front end other than setting up that gateway network connection, which is 30 seconds. And then the tag provider will be coming from that new IO gateway. So if you're properly designed there, then that can make it very convenient for continuing to scale out on the IO side. You do want to make sure that you use fully qualified tag providers as part of the path. This is done by default in Ignition 8.0 and 8.1. If you drag a tag out onto the screen, it includes that. But if you're typing this in by hand, having that fully qualified tag path makes it so that it is automatically portable. So if you export that project and you import it in somewhere else, if you move that tag provider, as mentioned, if you have a project that is pointed at a certain location and then it gets pointed to another default tag provider, if you have the fully qualified tag provider names, it's not going to change or break any of your tag paths as part of that process. So that can be a really important piece of a design choice as you go through. And then if we're taking a look at scale-out architecture with a load balancer, and you'll notice, I will mention this in a second, we added a little bit in the upper left there too. This scale-out architecture with the front-end gateways behind a load balancer allows you to scale out multiple front-end gateways. And so you can have 3 or 4 or 5 or 6, or you can have as many front-end gateways as you want there. And those front-end gateways are running exact copies of the exact same projects there. That load balancer takes any new client that comes in and connects it up to a different front-end gateway. So this would normally be someone who's running over 100 or 200 clients that are with relatively typical client design. So clients that take a certain amount of CPU, and maybe at 200, they're maxing out a front-end gateway, and it makes sense to scale out. So adding additional front-end gateways behind that load balancer will let you scale out in a clustered way. And every time that you might be running low on CPU, you can add another front-end gateway, and that'll just split the load there. Because all of the tags exist on those IO gateways, it doesn't add any tag load to the system. It only is adding more client load on the front there. And then, of course, those have communication to the IO gateways, but that communication is normally really efficient and relatively lightweight because that's subscription-based as well. Now, what this is showing in the upper left there is the possibility of the IO gateways connecting down to Ignition Edge. So that would normally be an MQTT connection that's going down to Edge for data transfer there, although that can be the gateway network as well. And then that Ignition Edge might be connected up to a few different devices. That'll have store and forward built into it and push information back up if that connection goes down. So that piece is a part of the hub and spoke architecture here, and is pretty typical as architectures grow.